to page 2, and if you notice, I'm looking at the denominator here. The bottom of the page, at this information here about where the sine values are positive, where the cosine values are positive, where the tangent values are positive, and where they have negative signs also. But we want to focus our attention. I'm going to teach you a little bit of a rule. We're going to focus our attention. If you notice what I highlighted here, where I highlighted is where each of the trig functions is positive. So everything is positive in quadrant 1, which should make sense to you because our coordinate point, our x comma y, both of those values are positive. In quadrant 2, we know that the x coordinate is negative and the y value is positive. And so that helps us remember that the sine value, that's our y, is positive, but our cosine value and our tangent value will both end up being negative. In quadrant 3, tangent is positive, and the reason why is because, remember, our tangent ratio is y over x. So if both of those signs are negative, if we do a negative divide by a negative, it becomes positive. And then lastly, in quadrant 4, we know that our x value is positive and our y value is negative. And so that shows us or tells us that our cosine value has to be positive in quadrant 4. But our sine value, which is our y, is negative, and that means our tangent would be also. So the way a lot of people memorize this, there's a mnemonic device here where you put an A, S, T, C. And so this is telling us that all of the trig functions are positive in quadrant 1. The sine value is the trig ratio that is positive in quadrant 2. The tangent value is the one that is positive in quadrant 3. That means the other two are negative. And the cosine value is positive in quadrant 4. That means sine and tangent are negative. Now the mnemonic device, the ASTC, a lot of students memorize the expression, all students take calculus. I don't know who came up with this, how long ago, but it helps you remember the ASTC in each of the quadrants to help you remember where your trig functions are positive. So there's kind of another visual that you can use to help with this, and I want to point that out to you also, just because I think for those of you who are visual learners that this can be helpful. So I want you to think about the fact that you have learned now that the sine ratio is y over r, or in the unit circle, y over 1. So the sine value is positive where our y values are positive, and so visually that's telling us, that's not very dark. Let me go a little darker. Let's use this other color. Let's go with this. So sine values are positive in these two quadrants. So sine values are positive in quadrants 1 and 2. For cosine we know are the x values, where we look for the x values. And if we want them to be positive, then x's are positive over here to the right of the y-axis. And so that is in quadrants 1 and 4. And then lastly, let's talk about tangents. Tangent will be positive where the x and the y coordinate have the same sign. So we know it's going to have to be positive here because everything's positive there. But the other place where the tangent value is positive is actually over here in quadrant 3 because it gives us a negative x and a negative y. So if we do a negative y over a negative x, we get a positive value. So the tangent values are positive in quadrants 1 and 3. All right, so we're going to use this information in order to, along with our special reference angles, in order to solve some problems. If we slip back a few pages, we're going to have have a unit circle right in front of us. So if you notice, the top of this page is talking about reference angles. You can go back and do some more practice and review with those. But we're going to focus our attention down here at the bottom section, where it's saying find the exact value of each trig function, and I don't have a unit circle in front of me. And so we have to kind of just think through these. So we're going to use what we know about our reference angles and our quadrants that we just learned in order to actually come up with the answers for these. I'm going to put my little mnemonic over here, my ASTC, to help me. All students take calculus. So let's talk through these. So cosine of pi, well, we know that pi radians is at this particular location, and that the coordinate point at that location is -1, 0. That would be on the unit circle. And so to find our cosine value, we know we want to look at the x coordinate. And so that tells us then that the cosine of pi is equal to -1. For the second one, sine of pi over 3, well, pi over 3 we know is equivalent to, that in degrees, we know pi over 3 is 60 degrees. And so we want to think about what the coordinates would be at that particular place. Well, we know the coordinates at that are 1/2, 3, square root of 3 over 2. And we want the sine value. And so the sine of pi over 3 is equal to the square root of 3 over 2. All right. Those are pretty much basic unit circle. Let's talk about these others, though, because these are going to use a little bit more of what I was just referring to, using the mnemonic device, the ASTC, and also knowing what we know about our reference angles. So cosine of 4 pi over 3. So you may or may not even be able to think about where that is. That is equivalent to 240 degrees, so it would be about right here. But what I'm going to focus on is the fact that I'm seeing that it's something pi over 3. So I know it's a 60-degree reference angle. And I know it's in quadrant 3. And in quadrant 3, I know that my cosine value, the only value that is positive, is the tangent. And so I know my cosine value has to be negative. And I know that my 60-degree reference angle, if I look at the cosine value, then if I'm looking at the cosine value, I know I want to look at the x coordinate, and so I am looking at -1/2. And now I've got a double negative written there, so I need to erase. Okay. All right, onward. Let's think about this one, sine of 5 pi over 6. So I do know that if it's something pi over 6, then I know I'm talking about a 30-degree reference angle. And 5 pi over 6, I know is in quadrant 2. So looking at my mnemonic device up over here, sine values in quadrant 2 are positive. So I know my answer needs to be positive. And if I look at what my y value is at 30 degrees, my y value is 1/2. So it's a positive 1/2. Onward, 2 more. Okay, sine of 210 degrees. So the first thing I'm going to think about is the fact that the sine means I'm looking for a y coordinate. 210 degrees I know is in quadrant 3. And 210 degrees I also know is a 30-degree reference angle. So I've already seen that my 30-degree reference angle, my sine value is 1/2. Now I just have to decide on whether it should be positive or negative. So I know my value is 1/2, But in quadrant 3, sine values are negative because the only trig function that is positive there is tangent. So this has to be a negative 1/2. And lastly, cosine of 7 pi over 4. So 7 pi over 4. Cosine, I know I'm going to look for an x-coordinate. Something pi over 4 tells me I know I'm looking at a 45-degree reference angle. And 7 pi over 4, I know would be an angle that is in quadrant 4. So I want a 45-degree reference angle, and I want the x-coordinate at 45 degrees. And then I will need to think about if the cosine value in quadrant 4 would be positive or negative. So in quadrant 4, cosine values are positive. So I know my answer should be positive. And at 45 degrees, that's the special angle, that's the special point where the x and the y values are exactly the same, and it's the square root of 2. So the cosine of 7 pi over 4 is the square root of 2 over, the square root of 2 over 2. All right. I went through that pretty quickly. Hopefully you kind of can stop and pause and go back and listen to that if you need to. All right, so a few odds and ends to help you with unit circle information. We're starting on page 6, if you notice. And I've found that for some students it does help to kind of have this list that they can go back and refer to and to kind of help with practicing for reviewing. So we've got our 30-degree reference angles, because remember there are 30-degree reference angles in each quadrant. There are 45-degree reference angles in each quadrant, and there are 60-degree reference angles in each quadrant. So we've got what we know about a 30-degree angle is going to be true for our other 30-degree reference angles. So that's why it's helpful to know this information. So if we think about what the 30-degree reference angle in quadrant 2 will be, if we do 180 minus 30, we get 150. And if we do 180 plus 30, we're at 210 degrees. And if you do 360 minus 30, then we get to 330 degrees. So those are our 30-degree reference angles. And we need to write those in radians as well. So we know that 180 degrees is pi. So if we do pi divided by 6, that gives us 30. And then I've shown you this trick before. We talked about it when we were doing our unit circle. If we multiply 30 times 5, that gets us to 150. So that's why 150 degrees is 5 pi over 6. And if you multiply 30 times 7, you get to 210. So if you multiply pi over 6 times 7, you get 7 pi over 6. And then lastly, if you multiply 30 times, I didn't write in that times by 7, so times by 11, that gets you from 30 to 330, so that means 11 pi over 6 is equivalent to 330 degrees. This is helpful to know this, but I would strongly encourage you to truly just memorize these. All right, let's look at our 45s. So for 45-degree angles, these are the ones where you can just add 90. Once you start at your 45 degrees, if you add 90, you get to 135. Add 90 again, and you get to 225. And add 90 again, and you get to 315 degrees. So 45 degrees is equivalent to pi over 4 radians. And if we take 45 and we multiply by 3, that gives us 135 degrees. If we multiply by 5, that gives us 5 pi over 4. And if we multiply 45 times 7, that gives us 7 pi over 4. So there are our 45-degree angles. Those are the ones that are right along the diagonal that make the true X. And then lastly, we've got our 60 degrees. So let's look at those. So for 60 degrees, if we do 180 minus 60, we get to 120. We do 180 plus 60, we get 240. And if we do 360 minus 60, we are at 300 degrees. All right, and then radians, we know 180 divided by 3 gives us 60. So 60 degrees is pi over 3. And if you multiply by 2, that gives you 2 pi over 3 is equivalent to 120 degrees. If you multiply 60 times 4, you get to 240. So that tells us that this is equivalent to 4 pi over 3 radians. And then lastly, 60 times 5 gets us to 300 or 5 pi over 3. So you have to just memorize that the 30-degree reference angles are a pi over 6, 45-degree reference angles are a pi over 4, 60-degree reference angles are a pi over 3. That's very helpful information to remember along the way. Okay, we're going to use those reference angles a little bit more, along with some other information. So we're going to, part of your homework for this evening is going to be pages 8 and 9. So take a look on those pages. There are some problems there that are actually involve reciprocals. So I don't want you to do those. So you're going to cross off those two. And if you notice, you're going to cross off those as these 6 here in the middle of the page. But make sure you try the others. Use your unit circle, but also try to do this new technique with the reference angle and the All Students Take Calculus.